Okay, in the last video, we discussed the general characteristics of a homologous series, the homologous series itself, and we also saw a few examples of how we can determine the functional groups and the homologous series of alkene and alkenes. And in this video, what we are going to be talking about is the functional groups. The first thing, the functional group. In the second part, we will be discussing how do we name these organic compounds. So let's look at examples of some functional groups. We have seen for alkanes and alkenes, but it would be better if we just see for all of the functional groups of all of the elements that we are going to be studying in this entire organic chemistry part. So let's look at for alkene again. So alkane, we already established that it's going to look something like this. The element itself looks something like this, and the functional group is here the single bond. Okay, you can also say the carbon-carbon single bond or just a single bond. And the reason I'm saying it's the single bond, it's because this carbon can also exist, this alkene molecule can also exist as a single carbon. Okay, so this is CH4 and this is C2H6. So this is for alkene. Now let's talk about the functional group for alkene. Okay, how does it work for alkene? For alkene, if I draw a structure, so this is the structure of an alkene, and here this carbon-carbon double bond is the functional group. Now what you need to also know is that just like alkene can exist as a single carbon molecule, alkenes cannot exist as a single carbon molecule, because you need to realize that if you have to make a double bond, you need two carbon molecules, right? Because what we also studied that hydrogen can only make a single bond, only make a single bond. So if hydrogen can make only a single bond, and if I try to draw a single molecule of an alkene, so you will notice that there is no double bond here, which means a single carbon molecule of alkene does not exist. Alkenes only exist in a double carbon format, in a double carbon form. Okay, so here is the functional group of alkene. Now let's look at the functional group of alcohols. Now, alcohol, the functional group is something looks like this. The OH part is something that we call the functional group, but if I draw a structure for an alcohol, then it is going to look something like this. Okay, I think, wait, just let me draw another structure better. Yeah. So this is a two carbon structure of an alcohol, and we'll get into details of this with every topic. So this is an alcohol molecule, and this part here, which is this part here, is the functional group of an alcohol. Okay, now let's have a look at carboxylic acids. So for carboxylic acids, if I draw a structure, it's way easier to draw a structure and then figure out, because it helps you in forming the complete concept. Okay, so this part here is the functional group of carboxylic acid. This is also written as CO2H, or you can also call this COHH. Anything works. Usually this is the most preferred method, but you can also write it the other way. So this is carboxylic acid. Now the one thing that is left, that is esters. Now if I draw a structure for an ester, then it is going to be looking something like this. And there is hydrogen, and then you have C double bonded to an O, a C, NH, NH, NH. Okay, and I can understand that you guys might not be understanding all of this right now, and that's fine because we'll go into the detail in a while. So this part, which is a COO, this part is the functional group for an ester. Functional group for an ester. So these are the five functional groups, sorry, that we are studying in our entire course. Alright. Okay, now let's have a look at how are we going to name these organic compounds. Okay, naming organic compounds, and this is very easy. This is a very fun part of the organic chemistry. Okay, so let me take some examples. Before examples, let me just tell you that a name in an organic chemistry series is divided into two parts again. So these are the two parts. The one part is called the prefix, and the other part we call that a suffix. Now the prefix part here, this tells us the number of carbon atoms, number of carbon atoms present in the molecule. Okay, and the suffix part tells you the homologous series. And what do you mean by the homologous series? Now this tells you whether the molecule is an alkane, is an alkene, alcohol, carboxylic acid, blah blah blah. Okay, so these are the two parts this naming thing is divided into. Okay, so let's look at the table, and then you guys will understand it a lot better. Okay, so when we talk about the prefix, let me draw this table of sorts, and what we say that the prefix tell you the number of carbon atoms. Okay, so for example, if you have one carbon molecule, then you have two carbon molecule, then you have three carbon molecule, then you have four carbon molecules, and five, and then six. I think six would be enough for your understanding and for your syllabus right now. Okay, so if you have, let's say you have a one carbon molecule. Now a one carbon molecule means that the prefix part, the first part of the name, it's going to be meth. Okay, it's going to be what? It's going to be meth. If a molecule has two carbon atoms, it is going to be called eth. Okay, so if it has one carbon molecule, it is going to be called meth. If it has two carbon molecules, it is going to be called eth. And if it has three carbon molecules, it is going to be called prop. And if it has four carbon molecules, it's going to be called but. If it has five carbon molecules, you can call this pent, and six is called hex. Okay, one is meth, two is eth, three is prop, four is but, five is pent, and six is hex. Okay, so this is the first part which we call the suffix part of the molecule. Now let's move to the other part. Now that part is called the suffix, and this tells us the homologous series. How do we know? So for example, whenever in a carbon molecule you see, whenever in an organic molecule you see an ane written, A-N-E, ane, you know that it corresponds to an alkane molecule. Whenever you have ene, this corresponds to an alkene molecule. Whenever you have an OL, that corresponds to an alcohol molecule. Now, whenever you have OIC acid, you already know that this is a carboxylic acid. Okay, and when you have, I don't think you have it for esters though, so let's just leave esters for now. Okay, so these are the four things that you guys need to remember. And if you notice here, this is basically just being taken from the last part of this. So this ene comes from here, this ene comes from here, this OL comes from here, and this acid, OIC acid, comes from here. this part. So this is how you name organic compounds. Now, of course, the detailing has to come. We'll do a lot of examples when we move into the topic of alkenes individually. So yeah, this is it for now.